What is the hidden power of the interrupt vector table? Imagine a busy control center where every alarm, button, or sensor has a direct line to the right responder. That's what the interrupt vector table does inside a microcontroller. It's a small but mighty part of the system that manages how the processor reacts to different events. When a device like a timer or sensor signals an event, the processor needs to respond quickly. Instead of searching through a list of possibilities, it uses the interrupt vector table to find the exact address of the code that handles that specific event. This setup makes responses lightning fast and predictable. The real power of the interrupt vector table is in how it keeps things organized. It stores addresses, called interrupt vectors, each pointing to a special piece of code called an interrupt service routine. When an interrupt happens, the processor jumps straight to that routine without wasting time. This quick jump is essential in real-time systems where every millisecond counts. It also makes the system flexible. Developers can change or add new handlers just by updating the table without rewriting the entire program. This makes the system scalable and easier to maintain. Another hidden strength is how the table supports priorities. Some interrupts are more urgent than others. With vectored interrupt systems, each source has a unique vector, allowing the hardware to prioritize and the processor to handle the most important events first. This is especially useful when multiple devices send signals at the same time. The interrupt vector table also simplifies complex systems by centralizing all the addresses in one place, making the software cleaner and easier to troubleshoot. In some microcontrollers, the table can even be modified during runtime. This means the system can adapt its behavior on the fly, which is handy for applications that need to change how they respond based on different conditions. From a hardware perspective, the table directly links external signals like sensors or internal timers to the code that needs to run. This direct connection ensures the system stays responsive and stable, even when many events happen simultaneously. In practical terms, think about a motor controller or a sensor reading system. When a sensor detects something, the interrupt triggers immediately. The table ensures the processor jumps to the right code instantly, reading data or adjusting motor speed without delay. This quick reaction keeps the system running smoothly and reliably. So, the hidden power of the interrupt vector table is that it acts like a fast, organized guide for the processor. It ensures that every event gets the right attention at the right time, making embedded systems more responsive, flexible, and efficient. It's a simple yet powerful tool that keeps our electronics working seamlessly behind the scenes.